All right, so this is a 20-second problem, and we need to prove a limit that as x goes to infinity of the rational function x over 2x minus 8 is actually 1/2. Right, intuitively it seems reasonable. I'm going to go to the whiteboard to go through the steps, by the way. So let's go to the whiteboard. And we're on problem number 22 now. So problem number 22. This is the limit as x goes towards infinity. And then you get x over 2x minus 8. Now, when you took the pre-calculus courses, you did these limits over here when you did rational functions. And teachers told you to divide through the highest degree variable. And let me just write this down for you. If you did that, the limit as x goes to infinity, the highest degree variables actually get 1. You get a 2 minus 8 over x. Then they said, think about it. If x goes to infinity, the top would just be 1. There's no effect of x on the top, by the way. The bottom would be 2 minus something that does involve an x. But if x gets really large, 8 divided by really large number would be 0. So it seems reasonable. It's 1/2, by the way. But what's the deal over here? We need to prove this, all right? And the way we're going to prove that is use what's called an epsilon n definition. Let's write this down now. And what are we going to do? Given. And again, this is where a lot of teachers would say let. But anyway, given there's an epsilon greater than 0, what we're going to do now is choose. Now this is epsilon n definition, so we're going to choose an n now. I just don't know what it is yet, but it's going to be in terms of an epsilon. So what do we need to do now is, write down, suppose part, S-U-P-P-O-S-E. Well, I'm going to say there's some x that's actually greater than n. And I want to play it safe, by the way. And someone says, what do you mean safe? I want to be above the trouble number on the bottom. And what's trouble on the bottom? 4. So I want the n to be above 4. Now, what do I know about this? I know x is a positive number. I know n is a positive number. And I know those positive numbers are always going to be greater than 4. Now, why do I choose 4? There's a division by 0 at 4. So I'm just playing it safe. All right? What are you going to do now? Check part. What are you going to check? That the difference between the function and the limit value, and we're hoping that this leads to an epsilon. Let's take a look at it, and let's start writing things down, by the way. The first thing I want to point out is that there's a common denominator here. And if you factored it, it would be 2x minus 4. And what do you get here? Well, let's see, you just get x, right? Minus, well, then you're going to get x minus 4 in parentheses. What does this give me? Absolute value. There's a 4 here because x minus x is nothing, and minus 4 is 4. You get 2, x minus 4. Let me keep going. And I'm going to say absolute value of 4 is 4. The absolute value of 2 is 2, and 4 divided by 2 is just 2. Then what do you get? You get 1 over the absolute value of x minus 4. All right, I can keep going, and I'll tell you why I can do that. If x is greater than 4, the absolute value of x minus 4 is just going to be x minus 4. I can write this down now, 2 x minus 4. All right? Then the question comes, what's the next thing you could do? And there's a variety of things you could do, but I'm going to say, looking at this thing over here, x is larger than n. I'll write this over here. And that's larger than 4. They're both positive numbers, by the way. So I could say 1 over x is going to be less than 1 over n. That's not so bad, all right? Now, certainly someone says, what are you looking at? Maybe I'll write this a little differently, get my eraser out. And what I'm going to do is write this down instead. I'm going to write x, whoops, sorry about that. I'm going to write x greater than n. I know it's greater than 4, by the way. I'm going to say x minus 4 would be greater than to n minus 4. By the way, they're still positive numbers. They're still positive numbers. I could say something about the reciprocals now. 1 over x minus 4 is going to be less than 1 over n minus 4. And then you can multiply both sides by 2. Positive number, no effect on inequality. So what do I got over here? I got this now. What do I want to get? I want this to lead to an epsilon, and I think I'm almost there. Let me see if I can solve that. You get 2 n minus 4 equals epsilon, 2 over epsilon would equal n minus 4. And then I'm going to say 2 over epsilon would equal, I'm sorry, I went too quick there. I want to keep writing the same thing over and over again. Plus 4 is going to equal to n. So let's put this up here. I'm going to put 2 over epsilon plus 4. And we are now done. We did our proof, by the way. So QED. And again, black pen, red pen, puts a little box down, shades it in. Really same meaning. He showed what you're supposed to show, and that's a good thing. Bye-bye.